Well, in the last class, we started differentiation. So, what is differentiation? It is a process of getting derivative of a function. So, we have derived it also. We have taken sin x. With that, by using number of steps or procedure, we got cos x. So, whatever the steps you follow here, those steps or procedure is called as differentiation. Differentiation of sin x is cos x. We have used a method called first principle method. How it is to be obtained from sin x to cos x. So that procedure or the method is called as first principle method. We have derived for x to the power of n. The last class we got the derivative of x to the power of n. We got the derivative of sin x. We got the derivative of cos x. We got the derivative of tan x. So d by dx of x to the power of n is n into x to the power of n minus 1. In the last class, we derived derivative of x to the power of n. So finally, we got it as n into x to the power of n minus 1. So n may be any positive number, negative number, or fraction. Sin x, d by dx of differentiation of sin x. D by dx of sin x means differentiation of sin x with respect to x. We got cos x. Differentiation of cos x. Differentiation of cos x. D by dx of cos x is minus sin x. Differentiation of tan x, it is secant square x. So all those formulas we derived using first principle method. So based on the first principle method, you can get the derivative of any given function. So it may be a sum of algebraic terms, or it may be a product of algebraic terms, or quotient of algebraic or trigonometric functions, right? So this is the derivative of the standard functions. Like this, we can differentiate or we can derive it for cot x. For cot x, we will get minus cosecant square x. For cosecant x, we will get minus cosecant x into cot x. Cot x. For sin, cos, tan, cot, secant. For secant x, it is secant x into tan x. These are the derivative of trigonometric functions. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Differentiation of tan x is secant square x. For cot x, you will get minus cosecant square x. For cosecant x, you will get minus cosecant x into cot x. For secant x, you will get secant x into tan x. For e power x, you will get e power x only. For log x to the base e, you will get 1 by x. For root x, you will get 1 by 2 root x. Suppose if I take differentiation of 1 by x to the power of n. For x to the power of n, it is n into x to the power of n minus 1. For differentiation of 1 by x to the power of n, it is equal to minus n divided by x to the power of n plus 1. So like that, we will have the derivative of standard functions. So now I will discuss the rules of differentiation. First, I will write all the derivatives at one end so that it will be easy to write the derivative of standard function at required step. List of standard derivatives. List of standard derivatives. Number 1, d by dx of differentiation of x to the power of n is what? N into x to the power of n minus 1. Differentiation of x to the power of n is n into x to the power of n minus 1. So I mentioned example also. Differentiation of x, remember 1. Differentiation of x square 2x. Differentiation of x cube 3x square, like that. Second one, d by dx of x to the power of n. Sorry, 1 by x to the power of n. That is equal to minus n by x to the power of n plus 1. Suppose d by dx of 1 by x is there. What you will get? What is n? N is 1 minus n divided by x to the power of 1 plus 1. That is minus 1 by x to the power of 1 plus 1 is 2. Third one, differentiation of root x. Root x is also taken as standard derivative. Root x differentiation, it is 1 by 2 root x. Fourth one, d by dx of e power x. It is e power x only. D by dx of a power x. A power x is a power x into log a. A power x into log a. Here a will be taken as 1, 2, 3, 4, 5 positive numbers which should be equal or greater than 2. Sixth one, d by dx of log x. Log x, that is 1 divided by x. Differentiation of log x is 1 by x. Next, if I take the trigonometric functions, d by dx of sin x, it is cos x. D by dx of cos x, it is minus sin x. D by dx of tan x, it is equal to secant square x. D by dx of cot x, it is minus cosecant square x. D by dx of differentiation of next trigonometric function secant x, it is equal to secant x into tan x. D by dx of cosecant x, it is equal to minus cosecant x into cot x. If you observe the last class, there we have derived different derivative of sin x, derivative of cos x, derivative of tan x, and derivative of x to the power of n. So for those we need derivative using first principle method. For others, I have written directly. Please remember all these things are the derivative of standard functions, that is trigonometric as well as algebraic terms. Okay, now let us discuss the rules of differentiation. Rules of differentiation. Rules of differentiation. Very first rule, differentiation of any constant. If k is some constant, in place of y, if I take k, what is k? K is any constant. K is any constant. I should show that derivative of any constant is 0. Okay. So if I use the first principle method, you will get the answer for this. Take given thing y is equal to what? K. As x changes to x plus delta x, then y changes to y plus delta y. There is no x at all. It changes only in y. So y plus delta y is equal to what? K. If I take delta y is equal to k, transfer y to this side. That is what? Minus y. Then k minus what is y? Y is also k. That is equal to 0. Then divide by what? Divide by delta x on both sides. So it become what? Delta incremental ratio delta y by delta x. It is what? 0. Right? So if I take limit, if I take the limit as delta x tends to 0 on both sides, what you will get? Limit of delta y divided by delta x as delta x tends to 0 is equal to, there is no x at all, so it will be the 0. Then this is what? So 0 is our defined one, right? Defined function. So definable. Hence, we will take this as dy by dx. So dy by dx is what? 0. It means differentiation of any constant with respect to x is always 0. Sometime they will ask you, show that derivative of a constant is 0. So for that, you need to write all those things. Okay. So differentiation of any constant is what? Differentiation of any constant is 0. This is first rule. In place of only constant, if I take a function and a constant which are in product. Second one, in place of only k, if I take some variable k into u, k into u. What is k? K is any constant, and what is u? U is any function of x. U is what? It is a function of x. In that case, what happens? So for only k, remember, for only k is what? Any constant. If it is differentiated with respect to x, you will get 0. Please remember, derivative of any constant with respect to x is 0. Right? See the second step. What is second one? What is second one? Y is equal to what? Y is equal to k into u. So here, if I change x as changes to x plus delta x, then y changes to y plus delta y. What is u? U is function. Therefore, u also changes to u plus delta u, because it is a function of x only. Okay. So k into u, right? Delta y is equal to, delta y becomes what? K u, k into u plus delta u plus delta u. Transfer this y to right side. It becomes what? Minus y. Or ku, k into u plus k into del u by del u, only del u. Just multiply it. K into u into k into du minus what is u? Sorry, y. Y is equal to ku. So plus ku minus ku get cancelled. What is final term? K into delta u. K into delta u. Now divide that by delta x on both sides. Divide that with a delta x on both sides. What you will get? delta y divided by delta x is equal to k into delta u divided by delta x. What is next step in the first principle? After dividing with delta x, we should take limit, correct? Take limit as delta x tends to 0 on both sides. On both sides, it become what? Limit delta x tends to 0. Delta y divided by delta x is equal to constant. Now you take it outside, then apply the limit for the variable delta u by delta x. So as we know that u is function of x, right? It is a function of x. Then if the right hand side limit exists, then this will become what? This will become dy divided by dx, correct? K into. So this could be taken as du by dx. It means differentiation of a constant into function is always be equal to constant is kept as it is, and only the variable or only the function is to be differentiated. Got it? Differentiation of only constant is what? Differentiation of only constant is 0. Differentiation of only constant d by dx of k is equal to 0. And differentiation of k into u is equal to what? K into du by dx. Observe these two. Differentiation of only constant is what? 0. Differentiation of constant into function of x is what? Keep constant as it is. Function is to be differentiated. Got it? This is the second rule. Next, third rule. Suppose if the two or more functions, if they are in sum or difference, two functions, if they are in sum form or difference form. Third one, y is equal to u plus or minus v plus or minus w plus or minus and so on. It is called sum or difference. Sum or difference rule. The first one, what is first rule? Differentiation of constant is 0. What is second rule? Differentiation of constant into function. It is keep constant as it is, differentiate the function with respect to x. Third rule, if the function is having sum or difference of two or more terms, y is equal to u plus or minus v plus or minus w plus or minus and so on. Right? Here, take u. U is equal to plus or minus v plus or minus w. I will take only 3 terms, or either you can take 2 only. As x changes to what? X plus delta x. Y changes to what? Y plus delta y. But here we don't have x, correct? We have u, we have v and w. What are these? They are u, v, w, etc. are functions of x. Functions of x. What it means? Functions of x means u will be given in x only. V will be given in x only. W will be given in x only. Tan x, like that. So function of x means it will be in x only, right? Now, according to the first principle, if x changes to x plus delta x, automatically y changes to y plus delta y. We don't have x, but it is what? X term. It is what? X term. It is what? X term. So u changes to u plus delta u, v changes to v plus delta v, right? W changes to w plus delta w. What are delta V, delta U, delta W? They are all the increments in U, V, W. Okay. Change y into y plus delta y is equal to U changes to U plus delta U plus or minus V d delta U delta V by delta, we take only delta E. V changes to V plus delta V. I'll take only 2, otherwise you can take no problem. W. W is what? W plus delta W. This is Y, or delta Y becomes what? Delta Y is equal to U plus, if I take plus delta U, to derive sum or difference rule, either you consider plus or minus. You do it for first for plus, you do it for plus. I am deriving it for plus only. Okay. For sum, the same thing can be extended for difference. U plus delta U plus V plus delta V plus W plus delta W. Minus of what? Minus of delta Y become U plus delta U plus V plus delta V plus W plus delta W. Y goes to the other side. It becomes what? Minus Y. Then delta Y is equal to U plus delta U plus V plus delta V plus W plus delta W minus, what is Y? Y is equal to U plus V plus W. You consider it for only sum rule, right? U plus V plus W. In the next step, delta Y is equal to U plus V plus W plus delta U plus delta V plus delta W minus U minus V minus W. If I remove the bracket, I should multiply all the terms which are inside the bracket with the negative sign. So negative, if I multiply with negative sign, it becomes minus U minus V minus W. See, plus U minus U plus V minus V, W get cancelled. So I've taken for some symbol. Plus, the same thing can be extended for minus also. Okay. Now, what is our next step? We have to divide by delta x on both sides. So it become what? Delta y by delta x is equal to delta u plus delta v plus delta w all divided by delta x. So it can be taken like this: delta u by delta x plus delta v by delta x plus delta w by delta x. If I take minus here, so finally you will have minus symbols here. Here we got minus cancels, but here plus cancel. If I take minus UVW, they will cancel. We will have a minus here, so it will become minus. Okay. Now what is next step? Taking limit. If I take limit as delta x tends to 0 on both sides, delta y by delta x is equal to limit of delta x tends to 0, delta u by delta x plus delta v by delta x plus delta w by delta x. According to the theorem in limit, the limit can be extended for all the terms if they are in sum or difference or product or quotient. So then This is what? Dy by dx. This is dy by dx. This will become what? Du by dx. Plus this becomes dv by dx. Plus dw by dx. So this is called first principle method of getting some derivative rule. Or if I take minus here, what you will get? Dy by dx is equal to du by dx minus dv by dx minus dw by dx. Right? This is called what? Sum rule. Same way we can extend this to product rule as well as quotient rule. Product rule and quotient rule. To work out problems on differentiation, very important thing is you must remember the standard derivatives. You must remember the standard derivative and rules of differentiation. Rules of differentiation. I will list it out here. First one, y is equal to what? K. Then dy by dx is what? Dy by dx is equal to 0. Differentiation of any constant is 0. Second one, if y is equal to k into u, then dy by dx is equal to k into du by dx, provided u must be in x. U must be a function of x. Third one, sum or difference rule. So if y is equal to u plus or minus v plus or minus w plus or minus and so on, then dy by dx become du by dx plus or minus dv by dx plus or minus dw by dx plus or minus and so on. This is called sum or difference rule. Fourth one, product rule. Suppose if y is equal to product of two terms, here compulsorily both should be in x only. U and v should be function of x. Then its derivative become dy by dx is equal to, here we need to keep first function as it is and we have to differentiate second, plus keep second one as it is and differentiate first. What the product rule states, product of two functions, their derivative is what? Keeping first function u as it is, differentiate second one, plus keep second one as it is and differentiate first. Right? Next, fifth one, quotient rule. If y is equal to u by v, u and v should be in x. U and v should be function of x. Then dy by dx is equal to, so in product rule it is u into v. We have started with u, differentiated v, plus kept v as it is, differentiated u. Correct? In quotient rule it is u by v. We have to start with v. It is similar to, the rule is almost similar to product only, but here we start with v, that is denominator into differentiation of numerator. We have plus in the product rule, here we should have minus, keep u as it is, differentiate v, whole divided by v square, denominator square. Got it? So how we derived for sum rule? Constant into function. In the same way, we can also get this sum rule, product rule and quotient rule. Please carefully remember these rules of differentiation along with the list of standard derivative. They are very, very important. Then how to use them for a given problem? The problem will be of this type. Differentiate the following. Differentiate the following with respect to x. Differentiate the following with respect to x. The problem may be sum rule, on sum rule, or product rule, or constant, only constant, or constant into function. Let us go step by step. I will do few problems on first rule. Okay, then it will be easy to understand. First rule, y is equal to some constant 5. Here, what the first rule states differentiation of any constant is 0. Which are the constant? The term which do not have x, they are all said to be constants. Numerical values, algebraic terms other than x, trigonometric constant, exponential constant, like that. Okay, suppose if y is equal to 5, what is 5? 5 is a constant, so it is a first rule. Therefore, dy by dx is equal to constant. Differentiation of constant is what? 0. Second one, y is equal to a is what? We don't have x, no? We don't have x here. Therefore, differentiation of any constant is 0. Y is equal to sine 30 degree. Sine 30 degree. What is sine 30? It is off. Off is what? Numerical value. We don't have x. Here, we don't have x. Right? Therefore, it is treated as what? Numerical value. Whose derivative is what? Dy by dx is equal to 0. Y is equal to log of 15 to the base c. Observe this. We have differentiation of log x. Differentiation of log x is what? 1 by x. But here we have log 15. It is not x term. Okay. When there is no x here, it will be treated as constant. Right? So differentiation of constant. Log 15 is constant, whose derivative is 0. Y is equal to only e. We have e power x. Differentiation of e power x is what? E power x is e power x only. We don't have value at x position. That means what? It is a numerical constant. E is a numerical constant. So therefore, differentiation of numerical constant is 0. Suppose if there is a cube or a square, a is constant. We don't have x. Therefore, it is treated as what? Constant. Differentiation of any constant is what? 0. Got it? It is a first rule. So differentiation of any constant is 0. Which are all the constants? Numerical value, alphabets other than x term, trigonometric, ratio of particular angle, logarithmic, numerical value of some log. So they are all treated as what? Constants whose derivative is 0. Got it? In the next step, we will take problems on second rule. Problems on the second rule. What is second rule says? If the given function is constant into x terms, keep the constant as it is and differentiate the x term. Okay, that is second rule. The problems on second rule. Y is equal to 5 tan x. Y is equal to 5 tan x. If it is having only 5, it will be treated as constant whose derivative is 0. But here we have a product of constant and a variable x term. Constant into x term. Therefore, it is like second rule. Constant into function. Therefore, we have to apply this. Means what? This means what? Differentiation of constant into function. Keep the constant as it is and differentiate tan x. Differentiation of tan x is what? Secant square x. See the list of standard derivative. Differentiation of tan x is what? Secant square x. Y is equal to 2x cube. 2x cube. X cube is what? It is of x to the power of n form. Correct? X to the power of n form. X term into constant. Therefore, we have derivative. Dy by dx is what? 2 into differentiation of x cube is constant into differentiation of x to the power of n into x to the power of n minus 1. Correct? It is treated as what? X to the power of n. For x to the power of n, we have n into x to the power of n minus 1. It becomes 3 into 2, 6, x to the power of 2. Okay? So, you can write directly. If there is a power for x and there is index, you multiply the power and index. What happens? It is 2 into 3, 6. Then write x and write the power 1 less to the given power. So here we have 3, you should write 2. See third one, y is equal to 4 x to the power of 2. Then how to write directly? 4 into 2. Because constant 4 x square differentiation 2x. Then 4 into, for x square it is 2x. Otherwise, directly write like this, 4 into 2, 8 x to the power of 2 minus 1 is 1. Y is equal to 15 by x cube. 15 by x cube is nothing but what? 15 into 1 by x cube. So 1 by x cube is treated according to the second formula. D by dx of 1 by x to the power of n. So what is the answer? Minus n by x to the power of n plus 1. According to that rule, dy by dx become what? Dy by dx is equal to, keep 15 as it is because it is a constant. And derivative of the variable. What is it? Minus n. N is what? 3 divided by x to the power of 3 plus 1. Now, minus 3 is multiplied with 15. It is minus 45 divided by x to the power of 3 plus 1 is what? 4. Differentiation of 1 by x to the power of n is minus n divided by x to the power of n minus n plus 1. Y is equal to cot x divided by 2. So it is nothing but what? 1 by 2 into cot x, correct? 1 by 2 into cot x. So 1 by 2 is treated as what? Constant. Constant into x term. Therefore, differentiation is what? Dy by dx is equal to, keep constant as it is. Differentiation of cot x. What is differentiation of cot x? For cot x, it is cosecant square x, correct? Minus of cosecant square x. It is minus 1 by 2 into cosecant square x. So if you do such problems, do work out more number of problems so that you should familiar all the standard derivatives. So if you are very familiar with these standard derivatives and rules, it is very comfortable to work out more number of problems, right? You got it? Constant into function. Keep the constant as it is and differentiate the function. Keep the constant as it is, differentiate the function. Keep the constant as it is, differentiate the function. Keep the constant as it is, 15, and differentiate the x term. Okay. Then we'll go for third rule. How the third rule works? The third rule may include first rule as well as second rule, right? See, if y is equal to, what is the third rule says? Sum or difference. Cos x plus log x minus x cube. You may have any number of terms. I have written 3 for an example. Differentiation. Differentiation is what? Differentiation of cos x. That is d by dx of cos x. According to third rule, u plus or minus v plus or minus w, whose derivative is what? Du by dx plus or minus dv by dx plus or minus dw by dx. Individually, I am differentiating, right? D by dx of log x. What the sign you have? Write it. D by dx of x cube. I just applied the rule. Correct? Wherever we have d by dx, there you go for differentiation. Differentiation of cos x is what? Minus sin x. See the list. Plus differentiation of log x. Differentiation of log x is what? It is 1 by x. Right? Differentiation of x cube. Treat it as x to the power of n. N into x to the power of n minus 1. N is 3. X to the power of n minus 1 is what? 2. You practice, write directly. Okay, this is the derivative. So in exam, you need not be, this is compulsory. You can write directly this one. Write dy by dx is equal to differentiation of cos x is minus sin x. Differentiation of log x is 1 by x. Differentiation of x cube is 3x square. Y is equal to root x minus e power x plus a power x. Then dy by dx differentiate with respect to x. Differentiation of root x is what? 1 by 2 root x. Minus differentiation of e power x is what? E power x. Plus differentiation of a power x is what? A power x into log a. Differentiation of a power x is a power x into log a. Right? See this, y is equal to 5 secant x minus 2 root x. Basically, it is difference of two terms. Okay, this is x term minus of another x term. But if you look at individual term, how it is appearing? It appears like constant into function. Second rule. Basically, it is third rule. While differentiating, we should use the second rule. What is second rule? Constant into function. See, dy by dx is equal to 5 into differentiation of second rule. Correct? Minus 2 into d by dx of root x. Second rule. Totally, it is third rule. Function differentiation minus another function is there, differentiation. 5 into differentiation of secant x is what? It is secant x into tan x. Correct? Differentiation of secant x is secant x into tan x minus 2 into differentiation of root x is what? 1 by 2 root x. Better to write the derivative in bracket. So finally it will become what? 5 secant x into tan x. 2 get cancelled, correct? Minus 1 by root x. Let us take some more examples for third step. Y is equal to 5x cube minus 2x square plus 8x minus 7. How many terms are there? 1, 2, 3, 4. 4 terms are there. They are connected by different signs, plus or minus. Some are different. So it appears to be the third rule. It appears like the third rule. Differentiate with respect to x. Then dy dx of what? 5x cube minus dy dx of what? 2x square plus dy dx of what? 8x minus dy dx of what? 7. Here both the first rule as well as second rule is combined. Where is first rule? See the last term. What is last term? Only 7, which is what? Constant. See, differentiation of constant. See the other term, there appears like what? Constant into variable, function of x. Then how to differentiate? We have to keep the constant as it is. X term should be differentiated. Okay, dy by dx is what? Keep the 5 as it is, 5 into differentiation of x cube. Differentiation of x cube, 3x square. Whatever the values I am writing in bracket, which is derivative of x term. Okay, minus, keep the 2 as it is. Differentiation of x square is what? 2x. Plus, keep the constant as it is. Differentiation of x is, please remember, it is 1. Differentiation of x is 1. Differentiation of x square is 2x. Differentiation of x cube is 3x square. Differentiation of x to the power of 4 is 4x cube. Right? Differentiation of only x 1 minus differentiation of constant is 0. That is 5 into 3 what? 15x square. Minus 2 into 2 is what? 4x. Plus 8 into 1 is what? 8. This is the final derivative of the given function. Okay. So it's very important to apply the rules of differentiation. So this y is equal to 8 sin x minus 3 root x plus 5 to the power of x. 5 to the power of x. Constant into function minus constant into function plus function. So how many terms are there? 3 terms. Then we have to differentiate individually. Okay. While differentiating this 8 into sin x, differentiation of 8 sin x, constant into function of x, second rule. Keep constant as it is. 8 into differentiation of sin x is what? Cos x. Minus 3 into differentiation of root x is what? 1 by 2 root x. Correct? Differentiation of root x is 1 by 2 root x plus differentiation of 5 to the power of x. Which formula is there? Treat it as a to the power of x. A may be 2, 3, 4, 5, etc. A to the power of x is a power x into log a. Therefore, 5 to the power of x is what? 5 to the power of x into log 5. In place of a, we have 5. Therefore, a to the power of x into log a. While saying, you say the formula. While writing, you write the given term in place of a. Okay. Finally, it is what? 8 into cos x minus 3 by 2 root x plus 5 to the power of x into log 5. Y is equal to 1 by x plus 2 by x square plus 3 by x cube. What is given function? The given function is what? 1 by x plus 2 by x square plus 3 by x cube. Differentiate individually. It is what? Sum rule. Right? Dy by dx is equal to how? 1 by x is differentiated. On which formula we should differentiate it? See, 1 by x to the power of n is what? 1 by x to the power of n is minus n by x to the power of n plus 1. N is what? N is 1, correct? 1. Then, according to that, minus n by x to the power of 1 plus 1 plus 2 into differentiation of 1 by x square is what? 1 by x square, 1 by x to the power of n. See the second formula, minus n divided by x to the power of n plus 1 plus 3 into differentiate 1 by x cube. Differentiation of 1 by x cube is 1 by x to the power of n minus n by x to the power of n plus 1. That is minus 1 by x square plus into minus minus 2 into 2 4 divided by x cube plus into minus minus 3 into 3 9 divided by x to the power of 3 plus 1 is 4. This is the derivative. Got it? In this way, we can use the sum rule. So it includes what? Constant into function and the constant. Okay. Next, let us go for problems on product rule. Today I am going to work out 1 or 2 problems on all the rules of differentiation. In the next class, we will work out more number of problems. Okay. The problems on fourth rule. Fourth rule says that y is equal to what? Function into function. Function into function. See, we have no sign between two x terms. That is product rule. If there is a sign between, sign means plus or minus between two x term, then what we have to use? We have to use sum or difference rule. That is the main difference. Okay. If there is no symbol at all in between two x term, this is one x term, this is another x term, means it is a product of two terms. Treat it as u and v. If there is a plus or minus, then use plus rule, sum rule, or difference rule. What is u? First write the rule. D by dx of u into v is what? U into dv by dx plus v into du by dx. You can remember it like this. Keep first function as it is, differentiate second. Plus keep second function as it is, differentiate first. So alternatively, we should differentiate both the terms, but while differentiating first term, we should take it second term as it is. While differentiating second term, we have to take first term as it is. Okay. What is u? This. What is v? This. So I am applying it. dy by dx is equal to u. What is u? X square into d by dx of what? Sin x plus v. Keep v as it is. Keep the sin x as it is. Differentiate first function x square. You need not differentiate every term here. So we have applied according to the product rule. Wherever we have d by dx, only that term we have to differentiate. Here we don't have dy by dx, right, as it is. See here we have dy by dx term, differentiate. Plus here we don't have dy by dx term, write as it is. Differentiate dy by dx of x square, it is 2x. So finally, we can write it as x square into cos x plus 2x into sin x. This is the product rule. Take another simple example, root x into e power x. Root x into e power x. While reading itself, you can understand the problem. Root x into e power x. Into means product. You should go for product rule. If there is a plus or minus, you should go for sum or difference rule. Dy by dx is equal to what the product rule says. First identify which is u, which is v. Right rule. First keep u as it is. Differentiate v. Right. Differentiation of e power x. Plus keep v as it is. Keep v. What is v? E power x. Then differentiate u. What is u? Root x. I have written according to the rule, product of two functions. Then, as I said earlier, just wherever you have d by dx, that only term require derivative. Other terms we have to keep it as it is. See, keep root x as it is. Differentiate e power x, that is e power x only. Plus, keep e power x as it is. Differentiate root x, that is equal to 1 by 2 root x. So, e power x is taken common because in the both the terms we have e power x. What is finally remaining term? After leaving e power x, we have root x plus after leaving e power x 1 by 2 root x. Let us take another example. Y is equal to x square plus 3 into 2 plus cos x. See, last two problems we have taken simple terms, single terms, right? But here take u and v, they will be in what? They will be in sum of two terms or sum of three terms. It may be three terms, right? This is u, this is v. There are two brackets. Entire bracket is considered as u and v. Therefore, write according to the rule. What the rule says, u. What is u? X square plus 3 into what? D by dx of v. What is v? 2 plus cos x plus v. What is v? 2 plus cos x into what? D by dx of u, that is x square plus 3 u into d by dx of v plus v into d by dx of u, that is equal to keep x square plus 3 as it is. Differentiation of 2 plus cos x. Now we should apply sum rule, correct? So because we have sum of two terms, 2 into 2 plus cos x. What is differentiation of 2? 0. What is differentiation of cos x? It is minus sin x. So plus into minus become what? Minus sin x. Plus 2 plus cos x into what? Differentiation of x square, 2x. Differentiation of 3 is what? 0. Learn step by step. Then it will be easy. So now we have differentiated. It needs simplification. After differentiation, it needs simplification. X square plus 3. What is remaining here? 0. Leave it. Plus into minus, minus sin x. Plus 2 plus cos x into 2x. It is better to write in brackets. then it will be easy for simplification. Otherwise, it leads to complication. Now, how to multiply simplification? There are two brackets. We have to remove it. How to remove it? Just multiplying with a term of one bracket with all the terms of other bracket. Then, if it is having other term plus or minus, then you multiply with all the terms of first bracket. Okay. So minus sin x into x square. It is what? Minus x square into sin x. Here, sin of x is different and x square is different. So some will write like this, sin x cube. No, it is not permissible. So sin of x. Some people ask x into x square is x cube. No, why can't we write x cube? No, it is not permitted because it is a sin of x and it is only x square. So x is multiplied with only x, not of sin of x, right? Hence, it is x square into sin x. Plus into minus minus. 3 into sin x is sin x. Then multiply with 2x. 2x into 2. Plus into plus into plus. See all the sign first. Plus into plus 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 into plus plus. 2 into 2, 4x. Plus into plus plus into plus is 2x into cos x. 2x cos x. 2x cos x. If there are common terms having different signs, then you can get cancelled. Otherwise, write as it is. It is minus x square sin x minus 3 sin x plus 4x plus 2x into cos x. This is end answer. Okay. And so only one example on quotient rule. See, y is equal to 1 minus x square by 1 plus x square. Just see the question. Y is what? It is a function. Function of what? They are in the quotient form. Quotient form is numerator divided by denominator form. Okay. The whole numerator become u. Whole denominator become v. It is what? It is u by v form. Both should be in what? X terms. Now apply the rule. What the rule says, dy by dx is equal to v into du by dx minus u into dv by dx all divided by what? V square. dy by dx is v into du by dx minus u into dv by dx by v square. Just according to that, it becomes what? V is 1 plus x square into what? D by dx of u. What is u? 1 minus x square minus u. U is 1 minus x square into d by dx of what? V. V is 1 plus x square. All divided by what? 1 plus x square whole square. Right? I've just written according to the rule. Now I need to differentiate wherever we have d by dx. Other terms we have to keep it as it is. So 1 plus x square is kept as it is. Put a bracket, differentiate. This differentiation of 1. 1 is what? Constant. First rule. Derivative of any constant is 0. Minus for x square, it is 2x. Minus 1 minus x square is kept as it is. This is to be differentiated. Again, we have 1 and x square. Differentiation of 1, numerical constant 0. Differentiation of x square is 2x. Keeping the sign as it is. 1 plus x square whole square. So what the remaining? 0 minus 2x is what? Minus 2x. You can write like that. Minus 2x into 1 plus x square. Again, 0 plus 2x is what? 2x. 2x into minus 2x into what? 1 minus x square whole divided by 1 plus x square whole square. Then minus 2x into 1 minus 2x minus into plus minus 2x into x square. Here we can multiply x and x square. Okay, 2 into x into x square is x cube. Next, minus 2x into 1 is minus 2x. Correct? Minus into minus plus 2x into x square. Keep 2 as it is. X into x square is what? X cube. Whole divided by 1 plus x square whole square. See, if I have any common terms, minus 2x cube plus 2x cube, they get cancelled. Minus 2x minus 2x. If they are having same sign, then we should go for addition. Minus 2x is what? Minus 4x whole divided by 1 plus x square whole square. This is the answer after simplification. Okay. If the problem is of numerator by denominator, definitely you should take the whole thing in the numerator should be u and the whole term in the denominator should be v. You just write according to the formula. What the formula states, v into denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator square. Just write according to that. Then wherever you have dy dx, only that terms are differentiated, others are kept as it is. Okay. So after differentiation, no further differentiation is required. So only thing is simplification. Right? Say after differentiation, do you come across any dy dx? No. Then so differentiation is end. Only thing is we need to simplify it, right? Because in the later classes, again after differentiation, something is to be differentiated further, so that will come in chain rule. That's why I'm telling that. So if there is no dy dx, then differentiation is end of it. Okay. So in this class, we are familiarized with the list of standard derivatives and what are the rules of differentiations are there, then how they are applicable for a given function. Right? In the next class, we will work out more number of problems on all the rules of differentiation. So with this, I am concluding my today's class. Thank you.